Hi, in this Let's Create series, we're creating the classic block-breaking game of Breakout. In the last episode, we did the breaking blocks and accumulating of score. In this episode, we're going to do the final finishing touches. So when the ball misses the paddle, we will reset it onto the paddle. We will also implement the dynamic paddle bouncing, so depending on where the ball hits the paddle, it will move off in different directions. And finally, we'll implement the win condition. Let's get started. We'll start by removing the bottom wall, so you actually have to try to move the paddle. For this, select the bottom wall from the hierarchy, and we're going to simply disable the sprite renderer on it so we can't see it. Then, within the Box Collider 2D component, check the Is Trigger option. This means that the ball won't bounce off it, but it will produce a trigger event we can catch. Opening up the GameManager.cs script, we will add a public void resetBall method. Again, this is public, so we can call it from another script. Firstly, we remove the velocity from the ball by setting it to 0, which will stop it moving. Then we set isBallInPlay to false, which will stick it back to the paddle, using the logic we wrote earlier for before we launched the ball. In Unity, we'll create a new script called resetBall and attach it to the bottom wall. In this script, we need a reference to our game manager. Just to show you a different way this time, we'll serialize it so we can assign it in the inspector. Then create an onTriggerEnter2D method. This will happen whenever something collides with our bottom wall. The only thing moving that can reach here is the ball, so when that happens, we can just call the game manager's resetBall function. Back in Unity, let's assign the game manager reference by dragging it into the resetBall script and try this out. Wait, this is working well now. Next up on our final touches is to make the ball bounce differently off the paddle depending on where it collides along the length. In the game, if the ball bounces off the left half of the paddle, it will move to the left, and the right half will send it to the right. Furthermore, the nearer the edge it lands, the larger the angle will be. This diagram illustrates this. If the ball hits exactly in the middle, we expect the ball to bounce back vertically up, a little bit to either side and you get a shallow angle, and right near the edges you get a very extreme angle. It's important to note, for the gameplay, the angle in which the ball hits the paddle does not matter. This means it adds a skill element to the game to get the right part of the paddle where the ball will touch to get the ball going in the direction you want. So in Unity, let's create a new C# script. As it is the ball's rigid body, we have to alter to send it in the correct direction. I'll add the script to the ball, so let's call this ball and drag it onto your ball object. We need one private variable in the ball.cs script. This is of type rigidbody2d, which will use the shorthand RB as the variable name. In the start method, we'll get a reference to the rigid body attached to the script using the get component of type rigidbody2d. As this is on the ball, that'll be the ball's rigid body, which is exactly what we want. Now we'll add the onCollisionEnter2D method. This will be called whenever the ball hits anything. However, we only care when we hit the player's paddle to add this extra bit of logic. Add an if statement and we'll condition it on the objects which have been tagged as player. We do this by getting the GameObject reference of the collided object and using compare tag to see if it is the player. We'll add this tag to our player paddle later when we're back in Unity. We're going to create some logic that will give us +1 on the rightmost edge of the paddle and -1 on the left. We can then use this to alter our ball's velocity. For starters, we just want to know where the ball hits the paddle in the x coordinate. To do this, we'll take the ball's x position with transform.position.x, that is the transform of the current object the script's attached to, i.e. our ball, then subtract the x position of the transform attached to the colliding object, which will be our player paddle. This will give us a positive number if it collides on the right and a negative if it collides on the left. More specifically, the value at the rightmost edge will be positive half the paddle's width, So to normalise this to +1, we'll need to divide by half the paddle's width. Luckily, that's fairly easy to obtain. From our collision, access the collider, then the bounds method, which tells you information about the box collider, then the size, and finally x to get the x dimension. Due to the way this is implemented, this is exactly half the width of the collider, thus half the width of our paddle, so it's exactly what we want. So to our x calculation, we can now normalise this by dividing the difference in positions by our half width value. Now we have an x value between -1 and +1. We want to apply that to a vector 2 direction. Here I've used 4 times x for the x and 1 for the y. This means at the edge the ball will move 4 times more horizontally than vertically, and in the middle x will be 0, so it will go straight up. Now we don't want to affect the ball's speed, so the magnitude of this does not matter. So we will use dot normalize to give ourselves a unit vector. We do this so we can preserve the speed of the ball. So next, get the current speed, which is a float, which is the magnitude of the rigid body's velocity. Then we can set the new velocity as our normalized direction times this. As the direction is a unit vector, this means the magnitude of this is 1. So when we multiply by the speed, we've got the same velocity we started with in a different direction. Excellent. So in Unity, all we need to do to make this work is add the tag to our paddle. Click on the paddle in the inspector and change the tag to player. This is one of the defaults in my version of Unity. If you don't have it for any reason, you can use add tag to create one with this name. Now we can check it out. You can see in this first hit, even though the ball is travelling to the right, because it hits on the left side of the paddle, it goes off to the left. Then I try and hit it in the centre and fail miserably to hit it at all. Let's try that again. This time I hit on the right side and it goes off to the right. One final go. This time I'll try to hit the ball in the middle so we can see it goes roughly straight up. Excellent, got it. You can play around with this function if you want to change the paddle dynamics to better suit you. Maybe you want a bigger sweet spot in the centre or not so oblique at the edges. Have a play around and see what you like. Now the final thing to do is check for when all the blocks are destroyed and we've finished the level. For this, what we'll do is store all the blocks when we start the level and count how many are destroyable. Once they've all been destroyed, we'll show some winner text. So first up, we'll add a new serialized private game object called winText. This is what we'll show when we're done. Now we'll add some new private variables to our GameManager.cs script. Add a private block array called blocks. This will store all our blocks. Next, we have a private int total blocks, which we use to remember how many there were. And finally, another private int called blocks remaining, which is our counter to tell us when we're finished. To populate the blocks, we'll add back in the start method to the script. Here we'll populate the blocks array using find objects of type and passing in the parameter block. This will get all instances of the blocks. Then we can iterate over this using a for each loop, taking each block in turn. If the block is destructible, we increment our total blocks counter. We hadn't anticipated needing to access the isDestructible variable, so we need to quickly jump over to block.cs and change this from a serialized private variable to a public variable so we can access it. Then, at the end of the method, we set our blocks remaining to our total blocks, as that's how many blocks we've got to destroy. So in order to update the blocks remaining, we need to make some additions to our block destroyed method. Here, after registering the score, we'll decrement the counter. This is called for each block destroyed, so this will work fine. We can also check for the win condition here, as you only need to check each time you've destroyed a block. The win condition is if blocks remaining equals 0. The first thing we do is reset the ball using our reset ball method, as we don't need it bouncing around anymore. Then we call setActive, passing in true to our winText to show it. So back in Unity, all we have to do is create that winText. Right-click, UI text. Let's call this winner. And change the text to winner. Be sure it's in the center and align the text to the center. Then we can just make the text a bit bigger, and we'll need to make the game object slightly larger to contain it to stop it wrapping. We don't want this to display at the start, so we disable it to begin with. Then just drag this text object onto our new variable in the game manager. There you go. We've now finished the core game mechanics of this game. Here I am nearing the end of the level, and you can see that the winning text is displayed once I've finished. As always with the Let's Create series, I help you get to this point to kickstart your journey, and it's up to you to add the finishing touches. Some things you could consider include adding lives, as currently we have infinite, which makes the high score just a function of how long you play, implement different levels, make the ball go faster after each block is destroyed, camera shake on the block destruction, power-ups like multi-ball and sticky paddle, a high score table. There's so much you could do. As ever, the full code is on GitHub and linked in the description below. See you next time.